Hello and welcome to Physics Problems One by One. So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself. Today's question is about average speed. Initial speed, final speed, all directed there, and acceleration. And they want us to find average speed. So in order to find an average speed, we have to recall that this is distance d, and we need to find such a speed that if the body will be moving with the speed constantly, constant speed, no acceleration, constant speed, then within time t it will cover the same distance d as this body that accelerates. So we can say that v average equals d divided over t. Well, if you want to remember, v average multiplied by t equal d is absolutely the same. So, how do we find this? We obviously have to find d and t, but at the moment we have v initial and v final and acceleration a and d. So I pause here and then I will write the solutions that you suggest. Of course, distance d equals v final squared minus v initial squared divided over 2a, right? And the moment we have one square minus another, there should be like almost a reflex. A squared minus b squared, a squared minus b squared. And we always have to try to write this in this way to see what happens. So let's try here. D equals v final minus v initial, and here would be v final plus v initial. All I did was a squared minus b squared, a squared minus b, a minus b and a plus b. And of course not to forget denominator. And then I have v final and here v final. And so why don't I write this? And you will see in a second why I did it. And I split the denominator. This is like a multiplication of two fractions. All I did, 2 goes in this denominator, 2 goes in this and a goes here. And why I did it? Because this is acceleration, and during acceleration v final equals va plus at. So I put it here. I can say v final minus v initial equal at. It's all the same. So d becomes at divided over a multiply v final plus v initial over 2. A is gone, and I have the formula d equals v final plus v initial over 2 multiplied by 2. And just looking on this and comparing this to this, I immediately can of course say that v average in this particular case equal v final plus v initial over 2. So it's exactly like if we have two numbers, n1 for example, and n2, and then the average between those would be this. And if we have three numbers, then n3 divided over 3. But yeah, it's the first thing that kind of intuitively come to mind, that v initial plus v final, and we have to take divided into 2. But remember our very first problem when we have the distance, and on this distance we have 1/2 of a time body was moving with v1, and 1/2 of a time body was moving with v2, then of course the average in that case was exactly like here, v1 plus v2 over half. But remember, we had other case when the distance, half of the distance we were moving with v1, and half of the distance we were moving with v2, and the average was not that, but was something to that degree. I don't remember exactly, but I think I am correct. So what I'm trying to say, it's not always the case that it's average. In fact, this is just a coincidence, a huge coincidence, that we have A which is constant, and only because of this we have this average that is this. Only because of this. And this relates to the fact that if we draw the graph V over T, and this graph would be like this, and this would be V initial, and if this time T, then this would be V final. And if we want to draw an average speed, we have to draw it here in such a way that this rectangular, its area should be V average this side multiplied by this V average multiplied by T, and it would be D, and it would be exactly the same like area of this trapezoid. And this is possible only when this triangle is equal to this triangle. And so this area and this area are the same, and this is possible only when V average is exactly in between first and second. And this will happen no matter what time we have. The only important thing is that this is a straight line, and when this is a straight line, then there is a constant acceleration, and then it becomes so easy that this rectangle and this trapezoid and the areas should be the same. And the important thing that I want to digress here a little bit for 2 minutes maybe is that the fundamental fact is that, for example, if we have the speed going like this, for example, during the same period of time, V initial and V final, then the average would be somewhere here, so this area should be equal to this area, and it's just obvious that in this case this will not be valid. Average here is completely different, it's closer to the speed that's longer, executed longer during this period of time. But what's important, that this fundamental rule, that if we have T and we have V, and V goes not necessarily horizontal constant move, not constant acceleration, no matter how, then the graph of X at that period of time would be this area. And the graph of X in the beginning would be 0 because this area is very small, but then it grows because the area grows. At that time it would be this. At that time you calculate this area and the graph becomes like this. So what's very important that if you have graph of velocity, the coordinate is distance, is the area under this graph. And this is the foundation of calculus. And calculus was invented a long time ago, somewhere in 1670 or somewhere around it, in 17th century, and there was Leibniz and there was Newton, and Leibniz approached it from the mathematical point of view, and Newton approached it because he needed a tool for describing the motion and forces and everything in between. And so they developed from two independent positions this notion of calculus, and the notion of calculus is basically that the area underneath the graph of velocity is equal distance, and the slope tangent of this alpha on the graph of distance equals the velocity. And those are two simple things, and I don't want to talk about this anymore because they are outside of the scope problem one by one. But we're now comfortable with v equal v initial plus at s distance equals v0t plus at squared divided over 2. We're comfortable with this formula d equal v final squared minus v initial squared divided over 2a. We're comfortable solving those problems, but let's not forget that there is forest behind trees, and this forest is this calculus, and this is an extremely powerful thing, but I will not be touching this here. But for the time being, all I wanted to say that average for constant acceleration is described with a simple formula, and that the simple formula is direct result of constant slope on the graph of velocity over time, and this constant slope is direct result that acceleration is constant. And so if acceleration constant, this is true. In other cases it's not, and I wanted to make it very clear. Subscribe, bell, like, question, problem. See you next time. Thank you.